Tesla's early mover advantage won't keep it at the top forever. Well, Toyota will see to it. Their answer to Musk's hegemony is solid-state batteries. After years of focusing on hybrids and lagging behind in all-electric adoption, Toyota has unveiled a solid-state battery prototype that promises over 1,000 kilometers of range and ultra-fast charging in under 15 minutes. With over $13 billion invested in battery innovation and a rollout strategy that begins with Lexus and expands to mass market models by 2028, Toyota isn't just catching up. Its new battery may just as well crush Tesla's lead. Let's see how things are playing out with Toyota's late entry and rapid acceleration in EVs. Toyota is changing, and it's changing fast. For much of the 2010s, Toyota held firm in its belief that hybrid technology was the most practical path to carbon neutrality. This conviction was embodied in its flagship hybrid, the Toyota Prius, which debuted in 1997 and became one of the best-selling hybrid vehicles in the world. By 2022, Toyota had sold over 20 million hybrid vehicles globally. However, the tide has now turned. There is not going to be enough room for the middle ground in the future. It's either or, and Toyota realizes it. That being said, Toyota's pivot toward full electrification is beginning to take tangible shape. In 2023, Toyota sold approximately 150,000 EVs worldwide. This was a major leap. Just a year earlier, the Japanese automaker could only manage to sell a little over 24,000 EVs, mostly through its BZ4X crossover SUV and a few other regional offerings. The nearly five-fold increase in 2023 electric vehicle sales reflects both a sharp change in Toyota's production strategy and a growing global demand for fully electric options. Part of this new approach is Toyota's decision to use Lexus, the company's luxury division, as the vanguard for its most advanced electric technologies. Lexus, which sold over 824,000 vehicles globally in 2023, is not only a symbol of high-end automotive engineering, but also a strategic testing ground for Toyota's most premium innovations. The Lexus RZ450e, launched in 2022, marked the brand's first dedicated battery electric vehicle designed on the ETNGA platform, shared with the BZ4X. The RZ450e reflects Toyota's attempt to marry luxury performance with electric efficiency. Moreover, Lexus has announced plans to go fully electric by 2035, with some markets like Europe and North America transitioning even earlier. This staggered rollout allows Toyota to fine-tune its battery technologies, powertrain software, and production logistics before scaling up to mass-market Toyota-branded EVs. The company's renewed vision is encapsulated in its Beyond Zero initiative, a wide-reaching electrification campaign announced in 2021. As part of this initiative, Toyota has committed to achieving annual sales of 1.5 million electric vehicles by 2026. This target is ambitious considering that as recently as 2020, Toyota's EV output was negligible in global terms. To support this transition, the automaker has pledged roughly $13.5 billion in battery development and electrification by 2030. This investment covers not only new vehicle platforms but also battery research and development, solid-state battery trials, software integration, and the construction of dedicated EV production lines. By 2030, Toyota aims to offer 30 new electric models across both the Toyota and Lexus brands and reach annual sales of 3.5 million EVs globally. Toyota's global production network is also being restructured to support its electric ambitions. In the United States, Toyota announced a $1.3 billion investment in its Kentucky plant in 2024 to prepare for EV production, with the first U.S.-assembled EV expected to roll off the line in 2025. Simultaneously, a battery manufacturing plant is being constructed in Liberty, North Carolina, scheduled to begin operations in 2025, and expected to produce enough batteries for 1.2 million vehicles annually. In Japan, Toyota's Motomachi plant, one of its most historic production sites, is being revamped to serve as a key EV assembly hub. The company is also exploring production capacity increases in Europe, particularly in the UK and Turkey, where existing facilities can be upgraded for EV output. A $3.8 billion facility is slated to begin production in 2025 in Japan. The company is converting its Tsutsumi plant in Aichi Prefecture for solid-state battery production. These facilities will be instrumental in producing new solid electrolytes and battery materials such as lithium, nickel, and sulfide compounds critical for solid-state battery performance. Another cornerstone of Toyota's electrification plan is its electric vehicle platform architecture known as ETNGA, or Toyota New Global Architecture for EVs. Already used in the BZ4X and its twin, the Subaru Solterra, this platform is engineered to evolve with new battery formats, particularly solid-state packs. Toyota's solid-state batteries are projected to offer ranges between 1,000 and 1,200 kilometers per charge and ultra-fast charging in under 15 minutes. These improvements directly address common consumer concerns about range anxiety and long charging times, particularly in regions where public charging infrastructure remains underdeveloped. If successful, Toyota's technology could ease the path to mass adoption of EVs and drastically alter customer expectations around performance and convenience. This transition also represents a shift in focus for the broader EV industry. In recent years, the spotlight has often been on software innovations, from self-driving algorithms to over-the-air updates, a trend led by Tesla. Toyota's approach reflects a potential rebalancing of priorities, where the emphasis returns to materials, science, energy storage, and hardware reliability. This pivot could redefine how success in the EV sector is measured, particularly as regulatory pressures in regions like the European Union, California, and China tighten emissions and efficiency standards. This technological leap, however, is not without its significant challenges. The path to commercializing solid-state batteries is fraught with technical and manufacturing hurdles that have historically delayed their widespread adoption. A primary obstacle lies in the materials themselves. Solid electrolytes can be brittle, leading to issues with durability and the formation of dendrites, tiny needle-like lithium filaments that can short-circuit the battery. Furthermore, the precise and expensive manufacturing processes required for these batteries pose a major challenge for achieving the cost-effectiveness necessary for mass-market vehicles. Toyota's ambitious timeline will be a true test of its engineering and supply chain capabilities, pushing the boundaries of current battery production to an industrial scale never before accomplished. A primary obstacle lies in the materials themselves. Solid electrolytes can be brittle, leading to issues with durability and the formation of dendrites, tiny, needle-like lithium filaments that can short-circuit the battery. Furthermore, the precise and expensive manufacturing processes required for these batteries pose a major challenge for achieving the cost-effectiveness necessary for mass-market vehicles. The competitive landscape is also evolving at a breakneck pace. While Toyota advances its solid-state research, other automakers are not standing still. Tesla continues to refine its lithium-ion battery technology, achieving greater energy density and lower costs through innovations like its 4680 battery cells and structural battery pack design. Chinese EV manufacturers such as BYD are also making rapid gains with their own blade batteries and aggressive pricing strategies, capturing significant market share globally. Toyota's strategy could also accelerate broader changes across the automotive industry. While companies like Volkswagen, which partnered with QuantumScape, Ford working with Solid Power, and Hyundai have signaled interest in solid-state batteries, none have laid out production timelines as concrete as Toyota's. If Toyota achieves mass production first, it could force rivals to adapt or risk falling behind. Additionally, the transition to solid-state technologies may reshape global supply chains, reducing reliance on cobalt and increasing demand for other materials like sulfur or lithium in different chemical configurations. Despite its growing focus on EVs, Toyota continues to hedge its bets. The company remains committed to a diversified approach that includes hybrids, plug-in hybrids, hydrogen fuel cell vehicles like the Mirai, and combustion engines running on synthetic fuels. Still, solid-state batteries are increasingly positioned as the company's cornerstone for long-term carbon neutrality. If it delivers on the promises of longer range, faster charging, and safer battery systems at a competitive cost, Toyota will surpass the current EV giants, setting the pace for the next era of automobile innovation. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.